Hi guys, my name is Mayank Sharma and in the following video I will be solving the third question for given to us for the end term evaluation for the subject Mathematical Methods 2, that is subject code MAT104. So yeah, let's go ahead and solve the question. So the ODE given in this particular question right here is of the form is y double dash plus 25y equals 24 sine t, and the general solution for these type of ODEs is y is equal to y homogeneous plus y practical or particular solution. So first thing first, let's focus on getting YH, that is y homogeneous. For this we will be considering the RHS side of the equation as 0, implying y double dash plus 25y is equal to 0. So let's write a characteristic equation for this. That would be lambda square plus 5 plus 25 equal to 0, implying lambda would be the plus or minus 5 iota. And this equation right here is of the form a plus ib, that is iota b. And solution for these type of equations where the solution is of the form where lambda is of form a plus iota b is given by y is equal to e raised to 1 minus a t by 2, and in under bracket c1 cos bt plus c2 sine bt. Here a is 0 and b is 5, giving us y is equal to c1 cos 5t plus c2 sine 5t. This for homogeneous, and these are our, and c1 and c2 here are our arbitrary constants. So we have got our solution for the homogeneous y, and now it's time to focus on the particular solution of y, that would be yp, and it is given by, let me focus a bit, yeah, that'll be fine. And it is a spring mass system, and by using the basic rule what we get that the solution for the practical solution y is equal to a cos t plus b sine t. A and b are some arbitrary constants. So what we are going to do is find out y dash p and y double dash p, and then substitute into the equation given to us and compare the RHS and LHS so as to find the value of a and b. So let's follow along. Find yp dash, that would be, since a cos t, then it's going to be minus a sine t, 8 9 sine t, plus b cos t. Similarly, yp double dash will be given by minus a cos t minus b sine t. Let's substitute these two given into this particular equation right here. So what we're going to get is minus a sine t plus b cos t plus 25 times y, that's going to be minus a cos t minus b sine t, and we need not to basically, maybe minus a sine t plus b cos t plus 25 times y, not yp dash, that's the place I committed a mistake. Yp was a cos t plus b sine t is equal to 24 sine t. Let's solve it. What we're going to get is 24 a cos t and committing the same silly mistake again and again. Let's resume it on a fresh workspace and hope I'm not going to commit the same mistake here. It is yp double dash and I'm supposed to write. That is going to be minus a times cos t minus b sine t plus 25 times yp here was a cos t plus what was b sine t and RHS was 24 sine t. Simplifying it, what we get is 24 a cos t plus 24 b sine t 20 equals to 24 sine t. Comparing the LHS and RHS, what we get is a is equal to 0 and b is equal to 1. Therefore our solution yp is actually equal to what was yp and yp. So yp function of t, a was 0, so and b is 1, so yp here is sine t, and yeah, that's it. Therefore from what you can see, let's take it 2, let's take it 3, and the first solution that was 1. So referring to 1 and putting the values obtained from 2 and 3, what we get is that our solution yt here is equal to yh, that is y homogeneous plus y particular solution, giving us yt is equal to yh, that was c1 cos 5t plus c2 sine 5t and plus y particular solution, that is sine t, and that's it. So the solution, we still need to find the value of c1 and c2, and here's the thing, this question here was in ISP, that is IVP, that was initial value problem, given the fact that y at t equals to 0 is 1 and y dash at t equals to 0 is also 1. Let me check the question. Yes, so first thing first, let's find y dash t. That is going to be minus 5 times c1 sine 5t plus 5 c2 cos 5t plus cos t, and we would be substituting t equals to 0 in both of them. So for first, what we're going to get is equals to 0, c1 is equal to 1 from the first one here, and when we put t equals to 0 in y dash, what we are going to get is 5c2 is equal to is 5c2 plus 1, it is going to be 0 anyway, is equal to 1, cause y dash for t equals to 0 is 1 already. So yeah, implying c2 is equal to 0. Let's put c1 and value of c1 and c2 in the value obtained. Then we will be getting the final general solution, final solution basically, that is going to be cos 5t plus sine t, and that's it. And according to the question, we need to plot the graphs too for this question, so let's get another worksheet for this particular purpose, and let me zoom out it a bit. That seems perfect. So we need to plot y is equal to yp, and yp, as we have got, is sine t, implying to plot y is equal to sine t. We all know the graph of sine t. That is a simpler one. 0, just avoid the notch. T would always be equal to 0. And according to this question, what we're discussing here is the motion of a spring mass system, and a spring mass system in a steady state has a velocity of 0, implying yp dash here should be 0. There should be no change in velocity, and if there is no change in velocity, basically yp dash equals to 0, implies cos t here should be 0. So whenever the cos t is 0, that is the moment we realize that the system is in a steady state. The thing asked in the question is to sketch the graph of the solution curve, which is so difficult for my hand. So what I'm going to do is take support of some software for this particular purpose. So our solution was y is equal to cos 5 t plus sine t, and I have used maxima to plot this particular graph right here. So let me take the camera there. So as you can see, this would be the plot for our solution curve. This would be our solution curve. So yeah, that's it. That's my solution for the third question.